Today, we're going to look closely at the graphs and what you can do in terms of calibrating, editing, and annotating. Let's start with a recommendation for videos where the subject starts outside of the frame and then comes into it. Go to the point in which the body is fully recognized and then step back manually with your keyboard arrow or step button. This will ensure the joints are plotted correctly since the beginning. You can also trim to the appropriate places. You can also lock the inference to avoid unwanted rerunning of the model by clicking on the lock icon. Here, I'm turning off the traces for all the right-hand key points because they're not fully visible in many areas, and therefore the traces are less accurate and a little bit distracting. You can orbit the 3D graph by default if you click and drag within it. If you select the crossed arrows button on top of the graph, you can pan and select the area that you want to view or the area that you want to export. And you can zoom in and out as you would scroll with your mouse or trackpad while hovering over the graph. This will help you select the best views for each analysis that you're performing. We recently had questions about the axis numbers, for example. Here, these are pixels until you calibrate. 0 is at the bottom left corner of the frame. To calibrate in this video, I'm going to pick a moment where I'm almost straight. Enter my height, which is 5.5 feet or 5 feet 6 inches. I'm going to click on the heel and the top of my head, and then click Run Calibration. Voila! Now we have the frame calculated in feet. You can use whatever measurement unit you want. To create an annotation, just double-click on a trace. I'm selecting the right foot while it's on the ground as I come into the frame. Click on the text to edit and add your notes. Then just click outside the text when you're done writing. Here I'm clicking on the right foot on the ground as I exit the frame. Remember, you can drag the notes to rearrange them as well. And if you want to get rid of a note, just click the text and delete it. I'm doing this in the vertical displacement graph so I can know how much height I gained in my run and calculate the incline. My right foot went from 4 feet to 5.3 feet in height, so I climbed 1.3 feet. If we look at the horizontal displacement graph, we can see the same foot went from 27.4 feet to 0.9 feet for a total span of 26.5. This gives me a slope of 4.9% or a 2.8 degree incline. With this graph information and the annotating capabilities, we can get even more detailed data, like touchdown and liftoff times, span, flight times, frequency. But first, a reminder that all text in the graphs is editable. So you can title the charts, name the axis, and even the traces to your liking. And also that in the graph for joint angles, we present you with the center of mass position over time as a reference. Let's dissect this run in the vertical displacement graph. You can zoom into great detail by clicking on the magnifier glass. I'm using this to look at the exact moment the tip of my right foot lifts off the ground. As you can see, the height is steady and suddenly begins to lift. And there in the video, we can see that's where the foot leaves the ground. Now, I'm selecting when the foot touches down. by looking at the change of the slope in the right heel trace. Now we're going to do the same process for the left foot. When it's lifting and when it's touching back down. I'm going to repeat the process for each step. Keep in mind that I'm jogging up an incline and I have very short flight times. A real 10-yard fly will produce a very different graph with fewer, longer steps and greater flight times. As you can see, in just a couple of minutes, we got some valuable information about this run. With these notes, we can create a table comparing steps to check out symmetry between legs and concentrate on training to resolve specific deficiencies. For me, I can see a lot of variability in contact times, which is not great. Might be because I'm not an athlete or the uneven paving. I can also see that my left leg produces longer flight times. I'm pretty sure there's some deficiency in my right foot, as I've had plantar fasciitis a couple times. You can download images of each graph by clicking on the camera on the top right of it. You can dive as deep as you want into the data. Look at the different graphs and compare points as is appropriate for your testing needs with Factorial Biomechanics.